Welcome to LIB Academy again. Our question number 4. Now here that we have a trig problem and the integral is from 0 to pi on 2 and it's a trig function. We know that definitely it's a beta problem, and we are going to use the relation between sine and cosine as far as beta functions are concerned. So now this is the formula we need to know. How beta of mn equal integral from 0 to pi on 2 sine 2n minus 1 2n minus cos 2n minus 1 sine 2n minus 1 theta cos 2n minus 1 theta d theta. So now, and the other bonus formula that we need to know is Euler's reflection formula and the relation between gamma and beta. So now let's continue. So we would like to massage this problem to look like something like this, and we now look for our m and n. So we know that this one is the same as, can also be written as integral of 0 to pi on 2 tan is the same as sine on cos, right? So sine x on cos x, or on the root sine. So we can therefore go further and say integral of 0 from 0 to pi on 2 sine. We know square root of sine is the same as sine to the power half, right? X on cos to the power half x. So we want to get away with the fraction so that our problem will be more simple. So we just write this integral from 0 to pi on 2 sine 1 on 2x, because we are bringing this term up, so just negate the exponent. So cos minus power half x dx, right? So this is now our problem, and we are going to compare the exponent of sine and cos. So 2n minus 1 equal to exponent of sine, 2n minus 1 equal exponent of cos. So that is what we are going to do for now, to look for the value of m and n. So we can just go ahead and say half of beta of m and n equal that. So now let's look for the value of m and n. So we now know that this is the general formula that we are referring to. So looking at this, 2m minus 1 should equal half, right? So let's solve for m. Multiplying 2 by 2, I'm going to get 4m. 2 by minus 1, 2 equal 1. 2 crossing will give me 3, right? Dividing both sides by 4. So m equal 3 on 4. So let's also look for the value of n. 2n minus 1 should be equal to minus half, right? Minus half. So multiplying 2 by 2, we are going to get 4n minus 2 equal minus 1. 2 should cross, become positive 2 minus 1, positive 1. So 4n equal 1. Dividing 2 by 4 gives n to be 1 on 4. So now we said half beta of mn should be equal to integral from 0 to pi on 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta. Now we know the value for m to be 3 on 4 and n to be 1 on 4. So half beta of 3 on 4, 1 on 4 should be equal to our problem, because we've gotten the value for m and n from this problem, right? Should be equal to, let's write tan You can just represent it by this or that or that. It's just the same thing. So tan integral from 0 to pi on 2 tan x, sorry, dx. So now we are going to solve this alone. The value that we get will be the solution for this whole problem here. One of the benefits of beta functions allows us to solve some integral problems with ease. So using the relation between gamma and beta function, we know beta of mn equal gamma n all on gamma m plus n, right? It's raining here. So what we are going to do is that we have half, right? Half beta of 3 on 4, 1 on 4. So we can just go ahead and say beta, half beta of 3 on 4, 1 on 4 equal gamma 3 on 4, gamma 3 on 4, gamma 1 on 4, gamma 1 on 4, all on gamma 3 on 4 plus gamma 1 on 4, sorry, all on 3, gamma 3 on 4 plus 1 on 4. Yes. So now let's try to evaluate this. So 3 on 4 plus 1 on 4, this one right here gives us 1, right? So we can go ahead and say gamma 3 on 4. What am I writing? So gamma 3 on 4, gamma 3 on 4, gamma 1 on 4, all on 1, which is the same as that. But don't forget that we have a half here. This is somehow confusing, so don't forget it. So our half is still there now. So now we are going to look out for, to solve for gamma 3 on 4, gamma 1 on 4. And it turns out that since we have gamma 3 on 4 and gamma 1 on 4, and the bases are the same, we can just use a shortcut method, which is known as the Euler's reflection formula. So Euler's reflection formula is just that if we have mostly terms of this form can be solved by Euler's reflection formula. That if we have gamma of n comma 1 minus n, then it should be equal to pi over sine n pi. So what we want to do is that to look for a value of our n, and what you just do is that just equate 1 minus n to any of these terms here, either 3 on 4 or 1 on 4. So doing that, let's say I can say 1 minus n equal, I recommend you using this. I try using this. You can equate it to 1 on 4. No matter which way you go by, the value that you are going to get is going to show you whether you have to use it or not. So I'm equating to 3 on 4. No matter which way you use, you'll be okay. So 4 by, let's try to simplify this. We're multiplying through by 4. I'm getting 4 minus 4n equal 3. So minus 4n, let 4 cross to this side. So we're going to give me, I'm going to get 3 minus 4. So this whole side here is giving me minus 1 equal minus 4n. So dividing through by minus 4, I'll be getting positive 1 on 4. So it means that my n here is 1 on 4. So after you got your 1 on 4, this your 1 minus 1 on 4, you could see that it's the same as 3 on 4. So nothing changed, right? Nothing changed. So it means that this whole term here becomes 1 minus n. And your n is 1 on 4. Or better so, if you don't want to get confused, after you calculated for your n, just know that just write the other term which you did not touch, you did not use in calculation. So 1 on 4. Which one did you use for the calculation? 3 on 4, right? So 3 on 4, you could see that 1 minus 1 on 4 is the same as 3 on 4, right? 1 minus 1 on 4 is the same as 3 on 4. You can use that. You can use your calculator to confirm that. So 1 minus 1 on 4 is 3 on 4. So it's just the same thing that you are trying to manipulate it in a certain way that will favor you. So that is gamma 1 on 4, comma 1 minus 1 on 4. Comparing this to Euler's formula is okay. We have 1 on 4 here, 1 on 4 here. So we can just go ahead and say pi all on sine n, and our n is 1 on 4. So 1 on 4 pi. But don't forget that this is so far how we solve the problem up to, and we are trying to evaluate this one and come and multiply it by half pi. And we know that pi is 180, right? Pi is 180. So 1 over 4 multiplied by pi, which is 180. So 1 over 4 multiplied by 180 is going to give us sine, is going to give us 45, right? So this whole term here is giving us 45. So this can be written as pi on sine 45. And what is the value for sine 45? Square root of 2 on 2. So this problem now, so we have pi on square root of 2 on 2. So now let's go back to our main problem. So a whole of this term now is gamma 3 on 4, gamma 1 on 4 equal square root, equal pi on square root of 2 on 2, multiplying half, right? So just multiply everything here by half. So now let's evaluate this further. What is the bracket here? We can rewrite what is in the bracket here as 2 on square root of 2 multiplying half, right? Yes, we just turn this one upside down and multiply by that. So you will see that these 2 here can take care of these 2 here, right? So we are left, what is left, at the denominator side and the numerator side. At the denominator side, we have only pi multiplying by 1. So just pi all on the denominator side, we have root 2. So this is our final answer for the problem integral from 0 to pi on 2 square root of tan x. So equal pi on square root of 2. Thank you for watching. See you in my next video.